Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Let's see this problem. We are given a number and we have to find square of that number. But here we have one constraint that we cannot use multiplication, division and power function of math class in Java. Okay, so let's understand this problem with some examples. Let's say if number is 5, square of number 5 is 25, so the output is 25. If the number is 3, the square of number 3 is 9, so the output is 9. If number is 7, the square of number 7 is 49. So I hope now you have clear understanding of this problem. So let's pause the video and think about an algorithm to solve this problem. Okay, so I hope by now you would have written at least basic program to find square of a number. So let's discuss the brute force approach to solve this problem. The idea is really simple. What we have to do, we have to simply add number to itself n numbers of time, and n is equal to number itself. So for example, if we are given number 5, then we have to simply add number 5 to itself 5 times, and this is exactly equal to the square of number 5. So let's see the implementation of this basic approach. So in this implementation, we have a function with name find square without operator. This number is taking n as input, and in the first statement we are checking if n is less than 0. Basically we are handing for negative numbers. If number is negative, then we are converting that number into positive. In next line, we are initializing our result as 0. So next we are running loop from 0 to less than n, and in each iteration we are adding value of n in result. And after loop, we are simply returning value of result. Let's dry run this code and see how it works. Let's say n is equal to 3 and initial value of result is 0. When we run this program, our loop begins, and in first iteration our I is 0. So we add response plus n, and the value of response is 0, and the value of result is 0. So result is equal to result plus n, means 0 plus 3 is equal to 3. In next iteration, our I becomes 1. In this iteration, we are doing result is equal to result plus n. Previous result is 3 and the value of n is 3. So 3 plus 3 is equal to 6. In next iteration, our I becomes 2. In this iteration, result is equal to result plus n. Previous result is 6 and the value of n is 3. So the result is equal to 9. In next iteration, our I becomes 4 and that is not less than n. So this is the base condition, our loop stops here and we get 9 as output. Okay, clear. So the time complexity of this function is going to be big of n, as we can see it clearly that we are running a loop from 0 to n. So it is a linear order of growth. And talking about the space complexity, we are not using any extra or auxiliary space. So the space complexity of this function is going to be big of 1. That is a constant space. So we are taking big of n time to solve this problem and big of 1 constant space to solve this problem. So this is all about the brute force approach to solve this problem. But can we do it better? Yes, obviously. Think about in terms of binary representation of a number. Let me give you an hint. Just like previous problem, we are going to use the same approach in this problem also. It means think about a binary representation, and in binary representation we can express any number in power of 2. Think about it. So let's talk about the efficient approach. So here is the idea of efficient approach. Let's say the number is 5. So the square of 5 is equal to 5 into 5, right? But as we know that we can express any number in form of power of 2. So can we write 5 as equal to 2 to the power 2 plus 2 to the power 0? Because 2 to the power 2 is 4 and 2 to the power 0 is 1. If we add both the number, we get 5, right? So now if you multiply 5 with both the numbers, you get 5 into 2 to the power 2 plus 5 into 2 to the power 0. But the constraint is we cannot use multiplication operator. So what we do? We know that if we write 5 left shift 2, it is exactly same as 5 into 2 to the power 2. And we have seen these in previous problem. And here also 5 into 2 to the power 0 is exactly same as 5 left shift 0. and if you evaluate this expression, you get 25, and this is the square of 5. Now the question is, we just have to find the power of 2. Let's see how we are going to do it. So we are going to start from 0. So 1 left shift 0 is equal to 2 to the power 0, and that is equal to 1, and that is equal to less than equal to 5. Okay, after 0 we move to 1. 1 left shift 1 is equal to 2 to the power 1 is equal to 2, and that is also less than equal to 5, and so on and so forth. So basically what we are doing, we are here finding maximum power of 2 that is less than equal to 5. So here you can see that 1 left shift 3 is 2 to the power 5, that is equal to 8, that is not less than equal to 5, but 2 to the power 2 is equal to 4, that is less than equal to 5. So we finally got the highest power of 2, that is less than equal to 5. So we got power as 2. So what we do, we simply do 5 left shift 2. It is same as 5 into 2 to the power 2, and that is equal to 20. So we are very close now. So next we have to find next power, and next power is 2 to the power 0. But the question is, what is the number to which we are going to compare this? So till 2 to the power 2 we are done. So what we do, we simply update the number, and we do like 5 minus 4 is equal to 1. So now the number reduced to 1. Now we have to find highest power that is less than equal to 1. So again we start from 0. So 1 left shift 0 is equal to 2 to the power 0 is equal to 1, that is less than equal to 1. Okay, that's good. Let's move on to 1 left shift 1 is equal to 2 to the power 1 is equal to 2 less than equal to 1. It is not less than equal to 1. So we get the highest power as 0. So we have to simply do 5 left shift 0. It is exactly same as 5 into 2 to the power 0, that is equal to 5. And we are done. We simply have to add both the values and we get square of number 5, that is equal to 25. So this is the entire idea, and now we have to convert, or we have to implement this entire idea into code. So let's see how we do it. So here you can see the implementation of the above discussed approach. Here we have a function. In the first line we are checking that if the number is negative, if it is negative we are converting into positive. And then we are initializing two variables, one is target and one is result. I am storing value of number n into target, right? Why? Because I do not want to change the value of n. That's why I am storing it in target variable. And we are using this target variable for some other purpose. Okay. And then we are running a loop if target is greater than 0. So till target greater than 0, this loop is going to run. And inside of this loop, this piece of code is searching highest power of target that is less than equal to target. Okay. And once we get the highest power of 2, we are doing result plus n left shift I. N left shift I is exactly same as n into 2 to the power I. Okay. Do not get confused. And after result, we are reducing target by 1 left shift I. 1 left shift I is exactly same as 2 to the power I. Okay. And in the last, we are returning value of result. So let's quickly try run this code and see how it works. So for n is equal to 5, target is also equal to 5 and result is equal to 0. In first iteration, our t is greater than 0. It means we get into the while loop because t is 5 and 5 is greater than 0. Inside of the while loop, we are again running a while loop to calculate highest power of 2 that is less than equal to 5, and we got 2, right? So then we are calculating result is equal to result plus 5 into 2 to the power 2 that is equal to 20, right? And we reduces the value of t to 5 minus 2 to the power 2 that is equal to 1. Now the target is set as 1. So now we have to find a power of 2, highest power of 2 that is less than equal to 1. So in next iteration again t is 1 and it is greater than 0. So we get into the loop and again in internal loop finds out the highest power of 2 that is less than equal to 1. So it comes out to be 0. So we are again calculating result is equal to previous result plus 5 into 2 to the power 0 that is equal to 25. And Again we are reducing value of t by 1 minus 2 to the power 0, that is equal to 0. In next iteration it checks if 0 greater than 0, and this condition becomes false and we get out of this loop. And in this way we get our output as 25, that is the square of number 5. Okay, great. Now talking about the time complexity of this function, as we are dealing with left shift, so what left shift does is simply deal with the power of 2. And whenever we have such type of scenarios where we are incrementing or dealing with power of 2 or dividing a number with power of 2, it always comes out to be logarithm order of growth. So the time complexity of this function comes out to be big of log of n. And what about space complexity? As we are not using any extra space or auxiliary space here, so the space complexity of this function comes out to be theta of 1. That is constant space. It means we are taking big of log n time to solve this problem and constant space to solve this problem. Okay, so far so great. So before we end this video, let's have a quick recap of what we have done so far. So we are given a number and our task is to find square of a number, but with some constraint. So the constraint here is we cannot use multiplication operator or division operator or power function of math class. To solve this problem, we saw the brute force approach. In brute force approach, we are simply adding number to itself and numbers of time, and n is where n is equal to number itself. And the time complexity of brute force approach came out to be big of n, that is a linear order of growth. And after brute force approach, we saw the efficient approach to solve this problem. In efficient approach, we use the fact that any number can be represented in power of 2, and that is the idea behind efficient approach. And the time complexity came out to be big of log of n. So I hope you understand this problem really well, and now you know how to solve this problem using brute force approach and efficient approach. So this is it for this video. Thanks for watching and see you in the next video.